Now this doesn't look like a constant acceleration question because of this velocity expression here. If I differentiated this to get acceleration, just the first term, 2t squared, would differentiate to 4t, which is dependent on time and so not constant. So I'm going to have to use the variable acceleration method. I've got to find distance, and the integrating velocity will give me displacement, which is slightly different. So if I was travelling 10 metres in that direction and then 5 metres back, my displacement would be 5 metres from my original position, but I'd have travelled 15. So I need to be a bit careful and find out whether the particle turns. If it's turning, then the velocity will be instantaneously 0. So by setting the equation for velocity equal to 0, I can find out if there are any times when that happens. And indeed, there is a time at 3/2 and a time at t equals 2. So the particle changes direction twice. So just to map that out, at t equals 0, it starts here. After 1.5 seconds, it turns back on itself. After 2 seconds, it turns again. And then at 3 seconds, our journey ends. So that would all be on one straight line. I'm going to integrate to find displacement. So let's expand this out. 2t squared minus 7t plus 6. We'll integrate that with respect to time to give 2/3t cubed minus 7/2t squared plus 6t plus c. Now I don't need the plus c because I'm actually going to be integrating between limits. So now instead of integrating for the whole journey from t equals 0 to t equals 3, I need to integrate between 0 and 1.5, 1.5 and 2, and 2 and 3. Otherwise I would just get the displacement from here to here and it wouldn't include this bit here. So I've got 2/3t cubed minus So first of all, between the first two limits of 0 and 3/2, and then the same again between the next two limits, starting at 3/2 and going up to 2 seconds, and then the same again. And it's important to be writing this out in some way, either here or here, to show that you're integrating between three sets of limits. So this is between 2 and 3 seconds. Substituting in these limits here gives me 27/8. Substituting these limits over here gives me minus 1/24. And substituting these limits gives me 7/6. Now I just want the distance, so I just need the magnitude of this. So I don't want negative 1/24, I want 1/24. And I need to add these three values together to give 55/12. Or as a decimal, 4.58 to 3 significant figures. Marks wise, there's a method mark for you setting the velocity equal to 0 to find the 2 times, and an accuracy mark for finding those 2 times correctly. You do need both. This can be shown in putting these limits in here if the working isn't shown here, and you'll still get these 2 marks. One method mark for integrating with or without the c, and an accuracy mark there for all of these 3 terms correct. Another method mark for showing the 3 different integral limits for your working out, and then an accuracy mark for adding those together to get either the exact value or the decimal.